A very good morning to one and all. My name is Bhargav. Welcome to one more session on the topic microprocessors and microcontrollers. In this topic, I'm going to discuss 8051 microcontrollers pin description. As in the previous topic, we discussed the features and functionalities of 8051 microcontroller. Now, I'm going to focus more on the architecture based pin diagram of 8051 microcontroller. So, 8051 microcontroller looks like an integrated circuit, very small. We can insert, you can handle with, take care with your thumb. It has 40 pins, 20 pins on each side. So, if you observe, the IC of 8051 looks like 20 pins on this side and 20 pins on this side. Totally, it is a 40 pin integrated circuit. This kind of packaging is called as DIP, as in dual inline package, where both the sides have pins. So, in this class, I am going to detail about each and every pin and its functionality. Let's move on into the topic. So, generally in microcontroller, as I told you, there are 40 pins. Out of 40 pins, some pins are almost mainly for port operation. That means a port is nothing but it is the gateway of this IC 8051 to communicate with the outside world. In order to extend its performance or processing, it can connect to external devices, connecting as in interfacing. So, in order to get 8051 to interface with outside devices like memory devices or input devices like keyboard and output devices like display, motor, we need ports for this interfacing. In order to connect external devices like memory, IO devices, we need ports. So, port is the gateway for IC to communicate with the external world. So, coming to the functionality. So, port functionality is for data transfer between the microcontroller CPU, 8051 microcontroller CPU to the outside devices. It can read data. It can read microcontroller 8051 CPU can read data from output devices, output devices. It will take as input and it can send data to another output devices. It can take input devices from keyboard, it will take data and it will send the data after processing to the output devices, namely display device like an LCD display. Here, this particular communication is through ports only. So, input-output control is done, data transfer is being done. So, when the data is entering into the CPU, we call it as a read operation. When the data is sent out to the another device, it is called as a write operation. So, read signals and write signals can be initiated by the CPU of 8051 from the output and input devices. So, mainly for data transfer and controlling the input and output control, and also 8051 ports not only connecting to IO devices like input-output devices, it can be connected to memory also. Because 8051, as I told you in the earlier class, it has on the chip 4 kilobytes of ROM and 128 bytes of RAM. If whatever the program you store in the internal ROM or program memory, program counter will fetch the instructions from the internal memory ROM. If the usage is exceeded the maximum limit, if the 4 KB is fetched, and the next instruction program counter that is going to fetch is from the external ROM. So internal ROM it is used, and the next fetch will be from the external ROM. So if internal ROM is used, like if you in the cell phone, for example, if you have internal memory in a cell phone which is already having to the most usage, that means the usage capacity is limited, already it is used to the maximum limit, and automatically you can store data and accessory and extra data in another memory, that is a chip you can insert from external device. So external chip will be there, there will be a external slot for the mobile. So the external memory you can add, this is called as extended memory. So here actually when coming to memory operations, in inline memory and extended memory operations will be there. So for connecting IO devices, ports are used. For connecting memory also, we externally, while connecting data memory or external program memory, we use ports. So while coming to the ports, there are 4 ports in 8051 microcontroller. Actually there are 40 pins, overall 40 pins are there, out of which 4 ports are present here. In the 40 pins, 4 ports are there, namely port 0, port 1, port 2 and port 3. And each port will be having 8 pins. That means 8 plus 8 plus 8, that is equal to 32 pins only for ports. So if you go through the pin description of 8051, it is here on the screen. It is having port 1, port 2, port 0, port 3. These ports are used for external communication, that means connecting IO devices and memory. So while operating for IO operations, while if all the ports are used for connecting IO devices, all the ports P0, P1, P2 and P3 will be acting as bidirectional IO ports. That means, let us say this device is connected with a keyboard, and this device, this port pins are connected with a display device, and this particular port pins are connected to a motor, a servo motor. See, CPU of 8051 can send data, can receive data. That means bidirectional IO operation, when only all the ports are used for IO operations. As I told you, internal memory ROM is 4 kilobytes, internal RAM is 128 bytes, RAM is 128 bytes, ROM is 4 kilobytes. When internal memory usage is completed, automatically we can connect external memory. If the memory is not sufficient, we can add extra memory by using these ports. If you want to do these memory operations, then automatically 2 ports will be exclusively given for the memory operations. What are they? As from the diagram of this particular pin description of 8051, you can easily understand that port 0 and port 2 are particularly used for memory operations. In normal case, if all the ports are exclusively used for IO operations, all the ports will be bidirectional IO ports. And particularly when external memory, if we want extra memory to connect, then 2 ports for memory operations, 2 ports that is port 0 and port 2 are allocated for memory. That means these two ports, port 0 and port 2, whatever the lines I am drawing now, these that indicates bus. A flat ribbon cable in the form of bus, it is connected to memory. This is even memory, odd memory bank. So, these two ports exclusively used for memory operations. So, actually we can say 8051 microcontroller CPU will be operating in two modes. One will be on-chip mode, on-chip, off-chip. On-chip means CPU is using internal resources, either memory, registers, timers, whatsoever, and when it is operating in off-chip, it will be using off the chip. That means memory devices or IO devices connected via ports. So, as you already know that 8051 microcontroller data bus is 8-bit of size. The capacity of data lines are 8 data lines are there. That means data bus is 8-bit in size. And address lines are 16. Addressing capability, data bus will be 16-bit. Addressing capability is 2 power 16. That is the maximum memory we can externally connect is 64. ROM or RAM. When coming to ROM, in the case of ROM, internally already it has 4 kilobytes. So externally it is going to have 60 bytes. So when you add these, the overall maximum memory that we can interface both internally, externally, ROM is 64. But RAM is 128 bytes. We know this by discussing about the features in the last class. Now, in order to connect extra RAM, then we can use port 0 and port 2. For RAM, externally when connecting, we can have external RAM as size 64 kilobytes. So, in order to address each and every memory location, we need 16-bit address. So, 16-bit address like A0 to A15. So, these address lines, that means a memory is being accessed by a CPU. When memory is getting accessed by a processor of 8051, then we are going to have two memory lanes. That means, let me explain you clearly. This is a memory. Here we have 16-bit address written in the hexadecimal notation. So, this particular 16-bit address is, this one is lower order address and this one is higher order address. This lower order address is present on port 0. Higher order address is present on port 2. Higher order address as in A8 to A15 address lines. And A0 to A7 address lines are present on port 0. So, if you observe, so it is a mistake over here actually. There is no data here because the data lines are 8. So, D0 to D7, 8 data lines. This is present on port 0. That means data lines D0 to D7 and lower order address bus A0 to A7 are being multiplexed and present on and connected to port 2, port 0, port 0.0 to 0.7. That means here it contains AD0, AD1, AD2, AD3, AD4, AD5, AD6 and AD7. In order to decrease the bus cost and decrease the complexity of the circuit, both address lines and both the lower order address and lines and data lines are getting multiplexed, and higher order address is present on port 2. So for memory operations, 2 ports are already given, port 0 and port 2, where lower order address and data lines are multiplexed and present on port 0. And at what time the bus which is connected across port 0 contains address, and what time data, which time address and which time data. So that is purely based on this particular pin, which is called as address latch enable. If address latch enable is 1, that means the bus connected across this port 0 will be containing address. That means the bus will be acting as address bus. If ALE is 0, address latch enable, if this particular pin value, if this pin data 1, address bus will be present. When it is 0, data bus will be present. That means the bus will be acting as data bus. And there is no multiplex lines across port 2, only higher order address lines are present. Obviously, it will only have higher order address lines. So when a data is being read, that means here this is a memory location and its address. If a 8-bit data is present over here, 08H. If CPU of 8051 is trying to read the memory 0000H, where 08 is present, during the first clock cycle, fetch will happen, next decode will happen, and execute will happen. Generally, first 2 clock cycles, fetching of the data. During that time, the bus contains address, and after the fetching is done, during decode and execute, generally ALU will be 0. Obviously, the bus contains data. It will be acting as data bus. So this mainly depends upon the fetching concept, fetching. So ALE divides or latches out data from address. If ALE is 1, bus is behaving as address bus. If ALE is 0, the bus will have data and it will be acting as data bus. So mainly we completed generally the concept of ports and its main functionality. It is to establish communication with the outside world devices. So whether it is memory or IO devices. So coming to port 1, mainly this one is used, it is purely IO device, IO ports, IO port pins. That means bidirectional IO port. There is no extra function, only IO device. It is solely used for IO operations. But as in coming to the port 3, port 0 is done, port 2 is done, port 1 is done, and remaining is port 3. Port 3, in normal case, it will be used for IO operations, but in some particular situations, it has alternate functions. It has alternate functions. The alternate functions is clearly described here. See, in normal case, I told you that is used for IO operation. In particularly, in alternate case, it has special functions where these 2 pins, port 3.0 and 3.1, these pins are used for serial communication with another devices. That means serially data will be coming from the outside device, and the CPU of 8051 can send the data serially to the other devices, device 1. So we are establishing serial link with 8051 with another device. These 2 pins are used for serial. Generally, port 0 and port 2, port 3, port 1, all these are parallel ports. So which can incorporate parallel communication. But particularly port 3.0 and 3.1, these are used for serial communication. And next, subsequently, port 3.2 and 3.3, these are used for interrupt used as interrupt pins. Externally, devices connected can interrupt the CPU's main program execution by sending an interrupt at this pin as well as this pin. Externally connected devices can interrupt the CPU's main program's execution by sending an interrupt to these pins, INT 0 bar and INT 1 bar. That means external interrupt 0, external interrupt 1. At these two pins, we can send the data. Devices externally connected can send interrupts. So, port 3.2 and 3.3 are external devices pins, and port 3.4 and 3.5, this is particularly used as timer port pins, timer 0, which is a 16-bit timer, and timer 1, timer 0 and timer 1, timer 0, 16-bit timer 0 and 16-bit timer 1. So, timer main functionality is used to count the clock pulses generated by the clock circuit. For the processor or microcontroller to operate, it must have a timing reference and performance evaluation parameter that is provided by the clock circuit. Clock circuit is connected across these two pins, crystal 1 and crystal 2. That means pin number 19 and pin number 18 subsequently. Externally, a 30 picofarad capacitor is placed over here and parallel connection with a ceramic resonator. Another 30 picofarad capacitor. It was grounded here. And this is connected to external 2 and external 1. That means crystal 2 and crystal 1. So, this is an external clock circuit connected at these two pins. By using material, the ceramic resonator or a crystal, quartz crystal material, the frequency with this particular material resonates, that creates a clock wave generation with a frequency 12 megahertz. That is the operating frequency of 8051. So, this particular clock is used for synchronizing the internal operations of 8051. So, timer 0 and timer 1 will count the clock pulses and increments its value. Timer 0, it will count first clock pulse, count 0, second clock pulse 1, third clock pulse 2, and so on and on. It will count to the maximum, and again it will again flow back, again starts. When the timer reaches the maximum count, timer overflow will be done. Same in the case of timer 1. So, it will throw overflow interrupt, timer 0 overflow and timer 1 overflow in the form of an interrupt. So, internally only timer 0 and timer 1 will provide two interrupts. And serial communication pins receive data and transmit data. These two pins used for serial communication. Whenever any serial data, 8-bit data is received from another device, when the 8-bit data is received inside successfully, a serial interrupt will be generated. That means internally serial interrupt is there, timer 0 overflow interrupt is there, timer 1 overflow interrupt is there. That means the interrupt sources for 8051, it is actually overall 5 interrupt sources are there, out of which 3 are internal and 2 are external interrupt sources. So, interrupt sources, 3 internal and 2 external. 2 external interrupt resources will be coming and entering through this INT 0 bar and INT 1 bar. External interrupts, external devices that interrupt 8051 operation will be appearing at INT 0 bar and INT 1 bar. And port 3.6, 3.7 is particularly used to deliver control signals like read bar, write bar and read bar. For writing into memory, that means IO read, IO write, memory read, memory write. So, on the left hand side, this particular pin configuration is done. So, on the right hand side, we left port pin 31 and port pin 29. So we can simply call port 31, port pin 31 as external axis. Port pin 31 is port pin 31 is called as EA bar. To abbreviate, it is external axis, and pin 29 is called as PSEN bar, program store enable. It is called as program store enable. That means if this particular pin is enabled, if we want to enable this functionality, we have to, the pin value must be 0 because as it is an active low pin. If we want this function to be disabled, the value must be 0. The same applies to this pin as well. Program store enable, PSEN bar, and there is no bar for ALE. It is an active high pin. So program store enable, this particular pin, if we want this functionality to get enabled, 0 have to be present at this port pin 0 and 1 in order to get disable for enable, and disable and enable. External axis means if this particular value is 0, that means program counter, inside program counter is, or inside data pointer is fetching data from the external ROM or external RAM. If EA bar is active, we can make sure that program, that means the CPU of 8051 is utilizing either this or that. That means ROM, external ROM or external RAM. But to precise, to know what is which RAM is being, which memory is being accessed, that is defined by program store enable. If EA bar is 0 and PSEN bar is 0, that means external memory is being accessed. If this one is there, we can make sure that external ROM is being accessed. If this one is 1, RAM is being accessed. For external memory access, these two pins values are more crucial. So if EA bar is 0 and PSEN bar is 0, external ROM is used. If EA bar is 0 and PSEN bar is 1, external RAM is used. So what if I ask you one more question before leaving, signing off for today's session? What if EA bar is equal to 1? If EA bar is equal to 1, that means it is in on-chip mode. That means it is only using internal memory or any other resources present on the chip itself. And that's it for today's lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.